Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good day to all. My name is Faridah Binti Marsin and I am from the Malaysian Chemistry Department in Pahang. And I will be presenting to you one of our studies entitled The Effective and Facile Dispersive Microextraction of Tricyclic Antidepressants by Bio-based Sporopollenin Composite. The emerging contaminants are now a major concern. The new pollutants, such as new breed of pesticides, nanoplastics, and pharmaceutical residues, seep through our rivers and into our food chains and also our waters. The occurrence is alarmingly high. The antidepressant drugs with several mechanisms of action are used with a prescription. Several effects on aquatic species exposed to antidepressants have been reported, as the impact in gene transcription, reproduction cycles, predator defense, and nowadays specifically could change fish behavior and gender. Thus, the determination of these emerging contaminants should be addressed. Most of the extractions of TCAs is using solid phase extractions. Solid phase extraction gives the advantage of a greener and more simple way to extract and determine the analyte. However, it is tedious and usually clogs the tube. A more simple way of extraction is by using dispersive solid phase extraction that gives a major advantage of ease of extraction and using minute sorbent. However, we need to filter to separate the sorbent and matrix. To counter the disadvantages of these, MSPE or magnetic solid phase extraction was introduced. The combination of magnetic nanoparticle with sorbent will easily separate by an external magnet. Previous researchers have been applying it to carbon and silica-based sorbent. However, the backlash is it tends to agglomerate easily in water. That is why it is important to select a sorbent with optimum extraction efficiency and at the same time possess mechanical strength, such as polymer, to reduce agglomeration. Sporopollenin is one of the most chemically inert biological polymers. It is a major component of the tough outer wall of a plant spore and pollen grains. It is chemically very stable and is usually well preserved in salts and sediments. It has emerged as an excellent drug delivery and microencapsulation and is a great candidate for a potential biosorbent. Thus, it is important that we address the need to extract these pharmaceutical residues, so much so to prevent unknowing toxicity. These antidepressants are easily dissolved and dispersed in water, making it hard to extract. So we need to develop an adsorbent material that is suitable to extract the highly water-soluble analytes efficiently. Furthermore, in lieu of green analysis, we need to consider a greener alternative such as a more biodegradable sorbent or reduction of extraction solvents. And yet, to cope with ever-fast changing technologies, we need to develop a fast and simple procedure of analysis. In this study, we intend to develop a green MSPE sorbent by using modified biopolymer material functionalized with silica-based actives for the extraction of tricyclic antidepressants or TCAs. We prepare the biosorbent by modifying it with alkoxysilane derivative, which is cyanopropyl triethoxysilane, via sol-gel process, to not only encapsulate the magnetic nanoparticle onto the sporopollenin, but to act as an active sorption site for the extraction of TCAs. The sorbent was then characterized by several instrumentations. The SAM micrograph shows that the first step of magnetization of sporopollenin was a success, as it is depicted in the cavities of the sporopollenin. The addition of silane covers the cavity to secure the magnetic nanoparticles in the sporopollenin. The FDR spectra here shows that the magnetic nanoparticle did not interfere with the active site of the silane, which is the cyanopeak. And from the elemental analysis, 4% of the sorbent consists of magnetic nanoparticles, and the magnetization strength of the sorbent is efficient to be separated via external magnet. Once the sorbent has been optimized, the sorbent was then subjected to be used as sorbent for vortex-assisted dispersive microsolid phase extraction. The optimization of the extraction method was done systematically using RSM box-Benken design, and the 3 selected TCAs were chosen as analytes and is detected and quantified using a HPLC UV. For the optimization, a 3-factor, 3-level box-Benken design was employed to achieve the maximum extraction performance and to explore the interactive effect of the extraction time, desorption time, and pH sample. The ANOVA results shows that the significance was identified by the p-value, which is less than 0.05. Hence, the model term of each TCAs was highly significant at 95% probability level. And the p-value of lack of fit of the 3 TCAs was higher than 0.1, which implies the insignificance of lack of fit relative to pure error. The high value of R square shows the excellent correlation between the predicted values and the experimental results. And the low value of coefficient of variation shows the high degree of precision and reliability of the conducted experiments. These elucidated the adequacy of the model to determine the optimum conditions of the 3 variables. The Pareto chart from RSM generally indicated that all 3 variables are significant, but does not significantly interact with each other and are treated as individuals. The sample pH and extraction time gave statistically significant linear effect on the response, while desorption time had a little effect on the extraction performance of the TCA. Thus, the contour plot depicts the optimum points for each variable. Thus, we came up with the optimum values for the variables based on the maximum efficiency of the extraction. Other variables were categorical and done iteratively. From the MSPE optimization, the extraction procedure was subjected to perform analytical performance using the 3 respective TCAs. And also, we have done a sorbent reusability test, whereby on the 6 sorption-desorption cycles, we only notice less than 6% efficiency loss in extraction performance. From the validation, the linear range is between 0.9 to 500 ppbs, and with LODs as low as 0.25 ppbs for 3 of the TCAs. And the recoveries in 3 matrix waters, which is tap water, river water, and wastewater, are between 86 to 106%, with RSDs are as low as 5.92%. The HPLC chromatogram of the analytes show that the analyte peak separated without any interference from the matrix. And as a conclusion, Sporopollenin is a good candidate for a green sorbent, as it provides a good support and canvas for providing with active sorption sites for the extraction. The prepared sorbent used in MSPE is proven efficient extraction for the selected TCAs with good sensitivity and high accuracy. Overall, the developed method promotes a simple, rapid, reusable, and generally a green method, and is a promising alternative for determination of TCAs in water matrices. We would like to acknowledge the following for the aid they have given. And if anyone is interested in collaboration or any queries, I can be contacted through this address. Hope this could be a platform for us to share knowledge for future collaborations ahead. Thank you very much for your attention and have a great day. Assalamualaikum.